The second half of section 8.3 talks about a different special triangle. It's a 30, 60, 90 triangle. We're going to use this triangle to come up with a proportion just like we did for 45, 45, 90 triangles. So start by drawing an equilateral triangle. Label that triangle ABC. So let's label this one ABC. And then draw an altitude and call that BD. Now remember, an altitude forms a right angle, so we do have two right triangles here. AB is going to be 8. I want to find AD and I want to find BD. So we want to look at this right triangle, DBA. But before we do, to find AD, because it's equilateral, this entire side's 8. Since that's 8, the altitude actually splits it in half to 4 and 4. And so now I have two sides, 8 and 4, and I got to find the third. 80 is 4, so 4 squared plus x squared equals 8 squared. 16 plus x squared equals 64. X squared equals 48. Again, we're just simplifying, solving. We take the square root, we get the square root of 48. Now, you can't leave it a square root of 48. You have to make a factor tree. So 6 and 8 go into 48. Into 6 is 2 and 3. Into 8 is 4 and 2. And into 4 is 2 and 2. So we're left with 5 prime factors, 2, 3, 2, 2, and 2. We're going to circle the pairs of 2's. There's 2 of them, so 2 pairs of 2's means 2 times 2, or let's instead just write that as 4. Square root of the one left uncircled, which is 3. Now, what we just did there follows this reference triangle, just like when we found 45, 45, 90 triangles, they followed a reference triangle. Notice how 8 is twice as big as 4, and 4 with a square root of 3 after it is the height. So, across from the 30-degree angle is the 1. Across from the 60-degree angle is the root 3. And across from the right angle is the 2. So we're going to have a proportion 1 over leg, square root of 3 over leg, and 2 over hypotenuse. Now, how do we know which leg is which? Right above this, I always write 30, 60, 90. And let's move this down so we can actually see it. I always write 30, 60, 90 above this so that we know that the side across from 30 is this ratio, across from 60, and across from 90. Okay, so whenever we're setting this up, whichever side is across from 60 always goes with the root 3. Whichever one is across from 30 always goes with the 1. So let's go ahead and try this. We have 1 over leg, square root of 3 over leg, and 2 over hypotenuse for 30, 60, 90. So if this angle is 60, this one's 30. So 30 in y. And since I know the hypotenuse, I'm going to use that one. 2 over 6 root 30. I go ahead and cross multiply. 2y equals 6 square root of 3. And when I divide, y equals 3 square root of 3. Now, I could use either one of these to find x. It doesn't really matter, but notice that I didn't actually have to set up a proportion here. 6 is twice as big as 3. So if you know the hypotenuse, you can divide by 2 to get to this side. Let's go ahead and use y, our 30 degree and our 60 degree to find x. So 1 over 3 root 3 equals square root of 3 over my other leg, x. When I cross multiply, I get x equals, which is why it shows that one only one step to solve, 3 times square root of 3 times square root of 3, which is 3. So x is 9. Now in example 2, same setup. We have a 36, let's write it up here, 30, 60, 90. We have 1 over leg, square root of 3 over leg, and 2 over the hypotenuse. So this is across from the 60-degree angle, so I'm going to find my 30-degree side first. So I'm going to find n. 1 over n equals square root of 3 over 7. Cross multiply. Square root of 3n equals 7. I'm going to divide by square root of 3. N equals 7 over the square root of 3. Now we had an issue that you can't end with a square root in the denominator, so I multiply the top and the bottom by square root of 3. 7 times square root of 3 is just that, 7 square root of 3. And square root of 3 times square root of 3 is 3. So n is 7 square root of 3 over 3. And to get to m, I have to double it. Doubling this means I take the numerator and I multiply by 2. So m is 14 square root of 3 over 3. Because 7 and 14, you have to take 7 and double it to get to 14. Take a minute, read this one. Go ahead and start drawing an equilateral triangle. Each side in the equilateral triangle is what we need to find. We know that the altitude, let's draw that in, is 21. So I need to find first this side right here, because all three sides are the same. So 1 over leg, square root of 3 over leg, and 2 over the hypotenuse. Now, because it's equilateral, this angle down here is my 60-degree angle, and up here is my 30. So 21 is across from 60, and x is my hypotenuse. When I cross multiply, 42 equals square root of 3x. Divide, x is 42 over the square root of 3. Now we know we can't end like that, so 42 square root of 3 over 3. If it can simplify, we need to simplify it, and it actually can. 42 divided by 3 is 14. So we have 14 square root of 3, and we're looking for just each side. We did one of these with the 45, 45, 90 triangles. Now we're going to do the same thing with the 30, 60, 90 triangle. I want to find the perimeter of this trapezoid. So I'm going to break it into a rectangle and a triangle. Top's 12, which means this part's 12, and this part is 3, because the entire side is 15. So if that's 3, I need to find this and this. The reason I need to find y here is because this side is the same, so I'll need to add that as part of my perimeter. So to find x, so we have our 30, 60, 90 proportion. Let's keep writing it. The more times we write this, the more times we see it, and the better we get for an understanding. So I need to find out x first. Let's go ahead and find x. 30 is across from my 3, so 1 over 3 equals x is my hypotenuse, 2 over the hypotenuse, x equals 6. So my hypotenuse is 6. Now let's go ahead and find y. Y is across from 60 degrees, 1 over 3 like we had before, but this time I'm going to use square root of 3 over y. Cross multiply, y equals 3 square root of 3, and we're already done with that. 3 square root of 3, and same over here as well. So to find perimeter, I'm going to add up all the sides. So 6 plus 12 plus 15, so I've already added the left side, the top, and the bottom, plus the right side, 3 square root of 3. These first three are like terms. When I add those up, I get 33, plus, I can't add this together, I have to keep it separate. And our last example, find the perimeter of an equilateral triangle that has an altitude of 12. So, we're going with the same idea that we did before. Equilateral triangle, we have an altitude. That's not drawn like an altitude. Let's try that again. Oh, hang on. There's an altitude. And our altitude's 12. I need to find the perimeter. So I need to find one side, and then I know that all three sides are the same. So my proportion, based off my 30, 60, 90, 1 over leg, square root of 3 over leg, and 2 over the hypotenuse. So I know 12 is across from my 60-degree angle, and I know x is across from my right angle. Cross multiply 24 equals square root of 3x. X is 24 over the square root of 3. The only issue, again, cannot leave a square root in the denominator. So we multiply by square root of 3 over square root of 3. X equals 24 square root of 3 over 3. 24 divided by 3 is going to get us 8. So we get 8 square root of 3 for each individual side. Now that I have each individual side, the question was asking for the perimeter. The perimeter of this shape is 3 of those, 8 square root of 3, 8 square root of 3, and 8 square root of 3, or 8 times 3, 24 square root of 3.